video we're going to look at how we can deal with independent uncertainties. Remember that independent uncertainties arise from different sources. Now, if we want to add or subtract two values with an independent uncertainty, then we need to add the absolute uncertainties in quadrature. So this means that we need to apply Pythagoras' theorem to the absolute uncertainties. Let's consider an example. Let's say we want to calculate how far a plane has ascended over a certain period of time. If a ground station measures the height of the plane above ground to be 120 plus or minus 6 meters, and then 30 seconds later the sensors on the plane give the plane's height as 816 plus or minus 5 meters, we can calculate the height ascended by using 816 minus 120, which gives us 696 meters. Now, in order to calculate the uncertainty in this, we need to add the two absolute uncertainties in quadrature. So we do the square root of 6 squared plus 5 squared, and solving that gives us 7.8. So this tells us that the height ascended by the plane over those 30 seconds is 696 plus or minus 8 meters. Now, if we want to multiply or divide two values with an independent uncertainty, then we need to add the percentage uncertainties in quadrature. Let's consider an example. Say we wanted to calculate the density of something. The density of something can be calculated as the mass divided by the volume. So let's say that we had a mass of 568 plus or minus 13 grams and a volume of 505 plus or minus 5 milliliters. In this case, the density is equal to the mass over the volume, which is 568 grams over 505 milliliters. Now, grams and milliliters aren't especially good units to use, so let's convert this to kilograms per litre. So this is 568 times 10 to the minus 3 kilograms over 505 times 10 to the minus 3 litres. So those 10 to the minus 3 factors actually cancel out, and we end up with 1.12 kilograms per litre. Now, if we wanted to put that into SI units, which is meters cubed per volume rather than litres, we then end up dividing it by another 10 to the minus 3, which is effectively multiplying it by 1,000, and so we'd end up with 1,120 kilograms per metre cubed. So we've now calculated the density. Now we need to calculate the uncertainty in this density. So in order to do this, we add the percentage errors in quadrature. So the uncertainty in rho on rho is equal to the square root of the uncertainty in m on m, all squared, plus the uncertainty in the volume over the volume, all squared. So this is equal to the square root of 13 over 568 squared plus 5 over 505 squared. And so this gives us 0.0249, which if we want to present as a percentage, we multiply by 100, giving us 2.49%. So it's more normal to present our final uncertainty as an absolute uncertainty. So to calculate the absolute uncertainty, we just do the density times 0.0249. So the density is then 1.12 plus or minus 0.03 kilograms per litre, or in SI units, 1,120 plus or minus 30 kilograms per metre cubed. So to summarise, when dealing with independent errors, if we want to add or subtract our values, then we need to add our absolute values in quadrature. If we want to multiply or divide our values, then we need to add the percentage errors in quadrature in order to get the total percentage error.